Record, share screen. Are you guys being silly? Lauren being silly? No, that is not possible. Today is March the 6th. Today's Mr. Dishman's birthday, I believe.
Yeah.
Have you guys all said happy birthday? Do you guys know that my birthday is in 15 days? I will be 24. Times 2 plus 2. We don't want to talk about that. I'll be 50. Yeah. I have 15, 14 more days of not being 50. So, wahoo! I should go out and like try to run or something. Yeah, this is a long one. This topic takes over a week. I wouldn't be surprised if I don't quiz you on this until like what is 10 days from now, like next Thursday. And it'll just be honestly one topic, and there'll be like 3 or 4 assignments during that time. It's a lot. So the idea, first off, let's talk about compound interest. Is the way interest works, is basically if you invest money in something like a savings account or like a mutual fund, interest is money that you make off of your money, right? So a very simple example would be, say you invested $100. And we'll keep this super easy just for the sake of not having to use calculators for a little while. Let's say you got 10% interest, and we're going to assume that we're only using compound interest. Okay, there's something else called simple interest, and we can talk about that some other time. But simple interest does not compound upon itself, and that's why it's not very exciting. We will, again, discuss it at a later date. But the way compounding interest works is you get interest on your money, and that interest goes back into the account. And then the next time that interest is calculated, the interest is based off of the improved value. Have you ever heard of this before? So let's keep this simple, and let's say we're only going to just compound once a year. So we're doing 10%, and we'll call this compounded annually. Get used to the words like annually. What does semi-annually mean? Every 6 months, every half of a year, right? You're not ever going to see me put biannually because that's every 2 years, right? So if I want you to compound like mid-year and end year, that's called semi-annually. What about compounding quarterly? Every 3 months, every quarter, right? There's 4 quarters in a year, 3 months, 3 months, 3 months, 3 months. Compounded monthly, every month. That means 12 times per year. Compounded daily, 365.25 times per year. And the reason we add in the 0.25 is because every 4 years there's an extra day in February. And so when we talk about over the long haul, if I talk about money sitting in an account for 80 years, if I use 365 as my number of days in a year, I'm missing out on 20 instances of an extra compound, right? And so that's why we have to add in a 0.25 with daily for the leap year, which happens every 4 years. So those are going to be the common ones that you see. You're going to see annually, which is once a year, semi-annually, which is twice a year, quarterly, which is 4 times per year, monthly, which is 12 times per year, and daily, which is 365.25 times per year. So for this problem, let's say we're doing 10% and it's compounded annually. So this will be a super simple example that we can just work mentally. And then, of course, the formulas pop up and the you-know-what hits the you-know-what. So if Pablo invests $100 in an account and that account gives him 10% once a year, at the end of 1 year, he gets 10% of his $100. And what is 10% of 100? Good. So I'm going to write my interest in red. So he got $10. And what is his new account balance? So he now has $110, right? But the word compounding, it's very intuitive. Like it ought to just make sense. It's literally compounding. You use that word in English all the time. And so now at the end of the second year, how much interest does Pablo get? Not how much does he have right now. How much interest will he get at the end of this year where he has $110? What is 10% of $110? Very good. And so now Pablo gets, you see, more money. This time his interest, while it's still 10%, 10% of a bigger number is a bigger number. I don't mean to insult you by saying that, but that is something that we should know. So now Pablo got $11 worth of interest. And what is his new account balance? He now has $121. And we won't do this for very long. You'll get the idea. But now at the end of year 3, how much interest does Pablo get? He gets $12.10. So $12.1. And what is his new account balance? $133.10. You're fine. Everybody okay? You see what's happening, right? This is called exponential growth. It is not linear growth. Linear growth would be just, I get $10 a year. You go up by 10, up by 10. We're not going up by an amount, we're going up by a percentage, which is called exponential growth. And so at the end of the 4th year, how much interest does Pablo get? You guys know that to do 10%, you just literally move the decimal one place to the left, right? So how much does he get? He gets $13.31. And you can see that we probably want to stop soon, not because we don't understand it, just because it's going to get pretty annoying pretty quick. Bless you. And so if we add $13.31 to this, how much does Pablo have in his account? Very good. And this is where it starts to become a little bit clumsy because now we have more than pennies as far as our numbers are concerned. Because how much money would Pablo get then at the end of this 5th year? So he's going to get $14, but we need 0.641. And so we've gone past, we're in now to splitting a penny into 10 pieces. So we have $14.61 and then a tenth of an additional cent. So it seems practical that we would want to stop here. But if I asked you to do this 10 more times, you would A, be mad at me because that's annoying and rude, but you could do it, couldn't you? You could just keep calculating 10% and then adding it in and then calculate 10% and add it in. You could keep going and going and going. But again, it becomes pretty annoying beyond this point. You can see that we're getting more interest every year because again, we're taking 10% of a number that's growing. I hope that makes sense. Okay. So let's take a look at the situation if it were to be semi-annually, and you're not going to like this very much, but the way it works is, so let's switch this now to 10%, but let's change the word, and we're going to use our formula. By the way, this is almost like the last time that we'll do this by hand, so don't think this is what you're doing for the next 8 days. If I go to semi-annually, that means 2 times per year. Now, you might think, well, that's a screaming deal, right? So are you telling me that I get 10% in June and then 10% in December? Of course not. 10% is still what we call the APR. That's the annual percentage rate. So you're still getting 10%. However, because it's happening twice per year, Pablo gets 5% in June and then an additional 5% in December. And we will not do many of these because these really start to suck. Okay? So let's work this out. So I'm going to erase some numbers here because these numbers are going to change. But you've still got them in your notes so that we can compare a little bit. So 10% means he gets 5% and then another 5%. He's taking his 10%, but because it has to happen twice a year, 10 divided by 2 is 5 and 5. So what is 5% of 100? Say again? No. 5% is half of 10%. What was 10% of 100? So what is 5% of 100? Good. So Pablo gets $5 in June. Follow me now. That means that he now has $105. But that happens in June. So now when Pablo comes rolling into the finish line, and it comes down now to December when he gets his second compounding of 5%. And it's okay to use a calculator now for stuff like this. But what we need to do now is in December, we need to calculate 5% of $105. And the way you do that on a calculator is you type in 0.05 times 105. I like you guys who scramble to get your calculators, because if you don't let yourself be a part of these sorts of things, you just watch someone else do them. I think you tend not to get as much out. So thank you for your participation. So if we do 0.05 times 105, what did we get? Now, I don't mean, I'm not talking down to you. I just have to ask the obvious. You see now that he didn't get $10 in year number one. He got $10.25. So we can surmise from this then that if I throw in more frequent compoundings while I'm still just getting 10% interest rate, I'm going to make more money, because that balance builds more frequently and it has more chances to like build off of itself, if that makes sense. It's not substantial, is it? When we did 10% once a year, we got $10. When we did 10% broken over 2 times per year, we got $10.25. And of course, what do you suppose would happen if we went up to quarterly? You'd get more. You'd get more than $10.25. And what if we went up to monthly? You'd get more than that. And if we went up to daily, you'd get more than that. It's not massive, as you can see. You get 25 cents more, whoop-de-doo, at the end of a year. But it's something, and it's different. So that's what we're going to study here, is how do you calculate bank balances and account balances and things like that if things grow exponentially at different rates and at different frequencies. Okay. Now, of course, there's a formula for this. I know that if Mr. Spatz still taught here, he used to do a lot of this out in the ag shop, but I'm going to put a formula for you up on the board, and this will be now the first of about 200 times that you use this formula in the next 2 weeks. So when he pops up, you're welcome to copy him down and then say hello to him, because he's going to become your new math bestie. Are you ready? Here it goes. We, of course, are going to spend some time today talking about what everybody is. Like, there are 5 variables in that formula. There's A, P, R, N, and T. And we need to know who everybody is. Like, that's step 1, is to become intimately familiar. Like, we shouldn't still, by the middle of Wednesday, be talking about, like, who's R again? Like, yeah, okay, that ship should have sailed by about 10 minutes from now. So A is going to be what we call the final amount. So that's like the end of the problem, right? That would be like if I asked you a question like, all right, you invest $100 in an account that pays 6.3% annual interest compounded daily over the course of 40 years. A would be the answer to how much money you have at the end of that period. Anyone want to guess what P is? Nope. It's the buy-in. It's in life, we call that principal. It's the principal investment. But if you don't want to use the word principal, you can just call it the starting amount. So every problem is going to have a starting amount and then a final amount, like what has it grown to? I'm guessing you probably know what R stands for, but that doesn't mean we're not going to put it into our notes. What does R stand for? Say it again. It is the rate. Very good. It's the interest rate, and I need you to understand that it's the APR that goes there. So if it's 12% interest, you'll always put 0.12 right there. And you might want to make a note to yourself, always make sure that that is converted into a decimal. So like if it's 6.3%, that's 0.063. If it's 5%, that's 0.05. If it's 11%, it's 0.11. You know, we always move the decimal 2 places to the left when converting percents into decimals. There are 2 more variables, and I have 2 more colors to use. That's a good thing. Anyone want to take a shot at who n is? I just throw these questions out. It's not like I would expect you to know the answers. But you know how I said, like in semi-annually, how many times a year does it compound? Semi-annually. 2. Quarterly, how many times? Monthly. Daily. 365.25. N is the number of compoundings per year. What if it's annually? What would we put in for N? Just 1. That would become purposeless at that point. Like we wouldn't even probably put R over N. We would just switch it to regular R. Because dividing by 1 is a waste of time. And then we have one more, and I'm guessing that this one is pretty intuitive. Who is T? It's time. And this will always be expressed in years because our interest rate is expressed in an annual, 1 time per year. And not 1 time, but an amount per year, percentage per year. So those are the 5 characters in this play that we're going to, and this is only one of 2 formulas for the record, but we're going to stick with this one for a little while here. So those are your 5 characters. You'll notice that there's an n in the bottom of the fraction and there's another n up in the exponent. They're the same n. So if it was like monthly, you would replace both of your n's with 12s. Okay. So let's get to it. Let's do some simple practice. You're going to be using the living dickens out of your calculator. So if you don't have a good calculator, this might just be the best time for you to march on into town and go to Walmart or Target and get yourself a little $15 calculator. All right? Because I have them, but it's pretty annoying if you are always using mine, because then I sometimes wonder, like, well, what are you doing at home, right? So you should get one if you don't have one. Get a good one. And I can give you advice on what to buy if you need. So let's do a math problem. Get used to that formula, okay? So here we go. I'm going to be writing a lot. So if you invest $4,500 in an account that pays 8.31% interest, compounded monthly, how much would the account have after 30 years? For the record, again, if someone gave me like 2 days and said, I need you to do this by hand, I would say, A, you are a terrible person, and B, I can do it, but you're going to need to give me 2 days in a quiet room, bring in a pizza like once every 12 hours, and wish me luck and give me a really good calculator. I could do this. You could too. But the fact that it's monthly means you'd have to take your 8.31%, divide that into 12 equal pieces, and do that 360 times. Because if you compound 12 times per year for 30 years, that means you have to do 12 times 30 360 different instances of computing a compounded amount. Holy Toledo. Could we do it? Yeah, it would suck. So this is where the formula bails us out. So as much as you might learn to dislike the formula, and this next couple of weeks in this class, do at least appreciate that the formula saves us a ton of time, stress, pain. So the first thing I like to do is write down my formula, and I'll still be doing this a week from now when we're deep in the heart of this unit and you're starting to say dirty words. I'm still going to start every problem by writing down the appropriate formula, which in this case is A equals P times 1 plus R over N to the power of NT. It's 5 seconds, 6 seconds of your life that will always prove to be well worth it. And so what we're going to do now is we're going to play a game of fill in the letters. And the way these work is you're always going to know several of the variable values. You just won't know one of them. It's like a game. And so let's run through this paragraph here, the short paragraph, and let's pull out some numbers. So first off, A is what we don't know. So for A, I'll put a question mark. I don't know what A is. That's like the whole point, right? What is P? 4,500. That's your starting amount. That's what you go into it at the beginning and say, I'm putting this much in. What is R? Good. And let's practice right now the art. I've taken off lots of points over the years for this, of all things. Let's practice the art of converting 8.31% into a decimal. What would it be? Move the decimal point 2 places to the left. 8.31% is not a decimal. It's called a percent. Yes, it has a decimal point in it, but a decimal is something different. Like 50% is 0.5. 0.0831. Always move the decimal 2 places to the left. Siempre dos a la izquierda. Siempre, 100%. Always 2 places to the left. There are no exceptions to that. None. What's T? And finally, what is N? Is 12. So that is our cast of inputs. That's our cast of players, characters. And now I'm going to rewrite that white equation, only I'm going to change the letters that I can into numbers. So let's get to it. I don't need the paragraph anymore. I can scroll a little bit. I've got all the pertinent information that I need viewable on the TV right now. So let's get to it. I'm going to write A equals because I don't have a number for A. So that's what I should do. What am I going to put in place of P? 4,500. And then I'm going to copy down 1 plus, and then I'm going to put a cute little fraction. And what's going to go on the top of the fraction? 0.0831. What's going to go on the bottom of the fraction? 12. And in the exponent, you heard me say this number earlier today, about 2 minutes ago, we have to do N times T. And this ought to make sense to bright people like ourselves. 12 is the number of times per year. I do this for 30 years. If you do something 12 times a year for 30 years, you do it 360 times. That's N times T. So we're going to type this now into our calculators. I have my calculator here. Like I said before, I hope you have yours. I hope you can be a part of this. So all we have to type in this case is the math. These are going to get a lot worse when the variable we're trying to solve for is on the right side. But we come to love the problems when it says like how much will be in the account after. These are the freebies. Just let it ride. Type it in, hit enter, done. So on your calculator, you're going to do 4,500, and then you don't have to hit times. Any calculator will have a parenthesis. So open up a set of parentheses, and then just type in 1 plus, and then you just type in 0.0831, hit divided by 12, close the parentheses, And then all calculators that are scientific also have a power button. Do not use the squared button. If you're on a TI-30, use the button that looks like this. The little up arrow is your power button. If you're on a fancier, like a TI-84 or something like that, you also might have an up arrow. Some of you have a button that looks like this, like Y to the X, or maybe X to the Y or something like that. So I'm going to hit my up arrow, and then I'm going to type in 360. So I'm going to type that in real quick. Get used to this, by the way. You're going to be hitting this same sequence of buttons like this a lot. If you hit enter, you should get this, and I'm going to write my answer on the board, and this will be a good sign if you and I got the same thing, because that means that we're typing things in correctly. And we will always round answers only to the nearest penny, or anything to the nearest 2 decimal places. So we should have gotten $53,973.06, because at the end it came out to 5.98 cents, which of course would round up to 6. Did we all get that? This is a good sign. Any questions about that? That is one of 8 things that you will learn in the next day and a half. We're going to finish. The notes will take the entire hour today, and honestly, they'll probably take a decent portion of tomorrow as well. So you can look at that and say 1 down, 7 to go. Good? Okay. Let's switch it up a little bit here, and I'm sorry but not sorry to ask this of you. I need you to copy down another problem. So I'm going to type it, and you're going to write it into your notes. Let's say, how much would you have to invest at 5.08% compounded quarterly there to be $50,000 after 60 years? So I'll give you a moment, obviously, to copy that down. But as you do, let's talk about the situation. You start with some amount of money. You go down to some brokerage firm or something like that, and you cut them a check and say, I'd like this put into this account. And let's say this account reliably pays 5.08%, and it compounds itself 4 times a year, and it does this for 60 years. And at the end of 60 years, when you go down to withdraw your money, your money will be worth $50,000. So the question becomes, how much would I have had to start with, right? So let's run through, as always, the list of characters. Let's start by writing down our formula. And our formula, again, is A equals P times the quantity 1 plus R over N to the n-th. All right, let's start with A. What is A? Good job. So this time we actually know A, which is why this is a new problem and not the same as the last problem. What is P? Question mark. Very good. What is R? 0.0508. I've taken off hundreds of points in my career for knuckleheads putting that as 0.508. Good God. 0.508, that's ridiculous. That's 50.8%. It's just nonsense, right? Always move the decimal 2 places to the left. What's N? Nope. Four, remember that N will always represent the number of times per year. Quarterly means it happens 4 times per year. And finally, what is T? So it's pretty predictable that you're going to know 1, 2, 3, 4 things, and not know the fifth. That's just going to be where it's going to get frustrating and difficult is that the unknown guy sometimes will be A, sometimes it'll be P, sometimes it'll be R, and sometimes it'll be T. It'll never be N, ever. So let's get to it. Same idea, being good at working with a formula means just understanding how to put numbers in place of letters. And so here we go. The formula is up at the top of the TD. What are we going to put in place of A? So I'm going to write 50,000 equals. What am I going to put in place of P? P. If it's an unknown, it stays as a letter. And then I'm going to put open parenthesis 1 plus. What am I going to put on the top of my little fraction? 0.0508. And what am I going to put on the bottom? And then in my exponent, what am I going to put? 240. Very good. If it happens 4 times per year for 60 years, 4 times 60 is 240. So this is not just a put it in your calculator problem. This one we have to talk about algebra, how to solve an equation. You were on a roll until you said subtract. You would divide. Listen, that if I gave you an equation like 12 equals P times 3, that you would divide both sides. Like, I don't even think for a second that you don't know that. So really what this particular flavor of problem boils down to is I just need you to take the 50,000 and divide it by all this stuff over here. So if we want to figure out what P is, then we need to type into our calculators 50,000 divided by, open parenthesis, 1 plus 0.0508 divided by 4, close parenthesis, to the power of 240. If I type it in like this, will my calculator do the math in the order that I want it to do? You've known the order of operations since like the 6th grade. So I ask this again. Will my calculator do things in the right order? In this case, it will. I had to put the parentheses around all the 1 plus R over N junk. But then it's going to do that to the power of 240 first because exponents take precedence over division. So if you just type it in just like this, and I'll type it in along with you here, and then again in green, I'll write up what I get, and hopefully we agree. You should have gotten $2,418.66. Get that? So far, so okay. 2 down, 6 to go. What interest rate would be required for a $5,000 investment be worth $340,000 after 50 years of, let's do semi-annual compounding. Had to check my English there. So this time, think about the situation. I know I've invested $5,000. I know that when I come back in 50 years, that account will have $340,000 in it. And I also know that it will have compounded on itself twice per year. The question is, what is the interest rate that's doing its magic behind the scenes? I can't even fathom of how impossible this would be if you didn't have a formula. And I sit here in front of you and say, I have no idea how I would do it. No clue. But thank goodness we have this beautiful little formula. So again, step one, let's write down the formula and then let's lay out our cast of characters. So here we go. Formula is A equals P times 1 plus R over N to the power of NT. And then off to the side, what's A? 340,000. Notice I don't put dollar signs when I'm naming, at least I don't think I have been, maybe I have, but I generally don't put dollar signs when I name all my characters off to the side. They're just going to get in the way. So what is P? 5,000. What is R? Question mark. What is N? What is T? Good. That was efficient. I appreciate that. That's how efficient it should be. You know, we're in high school. We should be able to read a paragraph and discern this from this, from this, from this. All right. So let's play a game of changey letters to numbers and let's see what happens. So what are we going to put in place of A? What are we going to put in place of P? What are we going to put in place of R? Right. And what are we going to put for our 100? Good. Any questions about that? We didn't do any math. I mean, did 2 times 50. That's not really. That's pretty light work. Good to hear. You can maybe see where this is going to be a problem is that the variable this time is not out in the open. That's an issue. The variable's nanny boo-booing you from inside those parentheses. He's feeling pretty smug and safe right now because he's like, you can't get me because I'm inside. We can get him out, and we will. It's going to take a little bit of creative working, but we can get him out. This is where the difficulty really starts to show up. So I hope you're still alert. I realize this is a long day to sit here, but sorry. But this is where it starts to get tricky. I don't think those other ones were very tricky. Let's think about the math and the order in which we have to do things. Step one is we have to kill that 5,000. And how are we going to get rid of that 5,000? We're going to divide. So what I'm going to do is on the left side and the right side, and I'm going to type it into my calculator. I'm going to type in 340,000, and I'm going to divide it by 5,000, and I'm going to get the number 68. This won't always come out to that nice of a number. You might sometimes have to leave it as a reduced fraction, just because, like if it was 17 thirds, you wouldn't want to put like 5.7. You'd want to leave it as 17 divided by 3. But this one came out pretty. So we wind up with 68 equals 1 plus R over 2 to the 100. Now, I'm going to ask you a big brain question here. It's not fair to do this after 39, 40 minutes of notes, but here it goes. Do you have any idea what would be a good next step? There's something that we have to do. Can't, because there's a plus sign. Square root, you say? How could we get rid of an exponent? No. There it is. So I'm about to erase some work. So if anyone like was watching this, like if you go back and watch this like 5 days from now, just you already had all that work. You already saw it. I'm just going to clear myself some space. Here it goes. Pay attention. In order to free up the variable, the only way to free him out is to apply on this side of the equation a 100th root. Because as you know, powers and roots, so great job. I know you were saying that, and I appreciate that. Excellent thinking. The only way to kill an exponent is with a root. You know, I know in the last unit we were using fractional exponents, but our calculator is going to probably be more agreeable if we use, I don't know, roots. But anyways, I'm going to take 100th root of the right side. And if, hey, fair's fair, I also then have to turn around and take the 100th root of the left side. Good. So riddle me this. On the right side, this right over here, that one, what happens when the 100th root and the parentheses to the 100 power interact? What do they do? Go away. So on this side, I actually just wind up with this. And now ours not so smug anymore. Ours not like nanny boo-booing us anymore because he's like, oh crap, you got me. Like I'm out in the open now. It's open season. Yes, it is. So we have to do some math now to figure out what R is. Some basic algebra at this point. And we will talk about how to type in these fancy roots in just a moment. But in the meantime, let's talk about basic algebra. You were going to say something. What would we do first? Not worried about that yet. I need to talk about the algebra. I would subtract 1 and you should also. So the next thing we're going to do is we're going to take the 100th root of 68 and we're going to take away 1. It's just algebra 101. Forget that you're even talking about this right now and just go all the way back to when we first met. Subtracting 1 is the next logical step. And what would be the final step? We would multiply by 2. Because that's how you get rid of the R over 2. That's how you get rid of the 2 that's underneath the R. And that leaves us with our final answer. So the question now is, how in the God's green earth do I do a 100th root? Well, on your calculators, you have, depending on what version, I'm assuming a lot of you use the TI-30. You guys should see a button on your TI-30 that says this. Don't use that. That's the square root button. You should also see a button that above it says this. Use that one. That's the modifiable root. That's the give me any root you want. So the way I type in a 100th root, let's practice this real quick, is you type in the number 100 first, and then hit second, and then that root button. So in your case, it would be like the up arrow button. So if I hit 100, and then I hit second up arrow, my screen looks like this, and yours should too. That's calculator notation for, hey, I'm about to take the 100th root of whatever you tell me. Got it? So let's practice. Hit that 100, hit that little fancy modifiable root button, type in 68, and then let's hit enter. And we should all get 1.0430979943. Match? With that on your screen right now, just leave it on your screen, hit -1, and hit enter. And of course, it's the same thing, just without the 1 in the front. And then what's the last step? So with it on your screen, hit ×2, and we should all agree that our final answer comes out as R equals 8.62%. Because what my calculator screen actually said was this: 0.086195887. So in order, we move the decimal back now to the right 2 places, and then we basically will round no further than that line. So 8.61, but the 1 rounds up because of the 9 that's to the right of that little green wall. So it's 8.62%. So if we backtrack, we now solve the riddle. We can say that 8.62% is the interest rate required to turn this into this over this period of time. And let's start the last problem, but we won't finish it today. So that's 3 down, 5 to go. And this one will be your least favorite of them all. You're going to like this one on the scale of 1 to 10. On the like scale of 1 to 10, this one's like a, which one's a 1? Could be like a -3. What is it? We're going to find T. Yeah. No dirty words allowed. Maybe. You can cuss all you want once you walk out the door. But here it goes. How long would it take for a $300 investment to become $13,000 with 5.07% interest compounded daily? This time, the situation has changed again. I know how much I invest. I know how much I want to get out. I know my interest rate, and I know the frequency of the compounding. The question becomes, does this take 20 years, 55 years, 36.24 years? Let's find out. So let's at least get the setup done here, but there's zero chance we finish this one today. We'll pick it up tomorrow after we give me a couple more minutes of your life, if you would be so kind, and then we'll pack up with time to spare. So step 1, what do we do first? Always write the formula, write the equation. Very good, you guys. Thank you for saying that. So let's start by writing down the formula. And today's formula, all we're doing today is this formula. Tomorrow we learn the continuous formula. It'll have E in it. So today's formula is A equals P times 1 plus R over N to the nth. You should probably have that memorized by now. Methinks. Here we go. What's A? Nah.
Oh, wait,
A is 13 grand. Remember, that's what you want at the end. What is P? 300. What is R? 0.0507. Well played on the 2 decimal place movement. What is N? Good job. And of course, what is T? Question mark, right? So there it is. Get used to it. There's your cast of characters, and we're going to plug them in, and then this will be what we finish class with, is this last parting thought. So don't pack up yet. Don't race ahead. This is everything we need. Here we go. What are we going to put in place of A? So it's going to say 13,000 equals, and what are we going to put in place of P? And what are we going to put in place of R? 0.0507. And what are we going to put in place of N? And at the exponent now, for the first time today, we're not going to have just a number. We're going to have a variable value, and you might know where this is headed. Your exponent isn't going to be a this times this. It's going to be an algebraic this times this. So in the exponent, we actually, sorry, I misjudged my clock. We need to write down 365.25 times t. And the last thing I have to say is this. How do we deal, you think, with an exponent that has a variable in it? Something that you get out of trees if you have an axe. You could build a cabin out of it. We're going to need logs. I'll see you guys tomorrow. Well, look at the bright side. No homework unless you're going to study up for that quiz retake.